Level 1, Electrical Engineering Freshman. You are 18 years old, and you are sitting in a lecture hall at Purdue University that holds 312 students. It is 8:30 in the morning on a Wednesday in September. The professor is drawing something called a phasor diagram on a whiteboard the size of a garage door. You do not know what a phasor is. You thought you would be learning about circuits. This is about circuits. That is somehow the problem. You chose electrical engineering because you took apart your Xbox at age 12 and your high school physics teacher told you that you were good with numbers. Neither of these facts has prepared you for IEEE 2100, Linear Circuit Analysis. The textbook is Electric Circuits by Nilsson and Riedel, 11th edition. It cost $180. It is making you feel personally targeted. Your TI-89 calculator cost $120. The professor just told you it is not allowed on exams. You write this down in your notebook as if writing it down will change it. On Thursday afternoons, you have a lab section in a basement room that smells like solder flux and carpet cleaner. You build circuits on a breadboard and measure voltages with a Fluke 117 multimeter. Your lab partner has pre-read every procedure. You have pre-read nothing. You measure a voltage of 3.4 volts when the answer should be 5 volts, and you spend 20 minutes convinced the multimeter is broken before your lab partner wordlessly swaps 2 resistors and the reading corrects itself. Your dorm room whiteboard is covered in Kirchhoff's voltage law equations that are all wrong. Out-of-state tuition at Purdue runs approximately $28,000 per year. Your parents remind you of this figure on Sundays. The first exam is in 4 weeks. You are beginning to understand that liking electricity and understanding electricity mathematically are 2 completely different relationships with the same subject. The coating of excitement underneath the confusion is thinning, but it is still there. You pass the exam with a 67. The class average is 64. You feel something shift. Level 2, Electrical Engineering Junior. You are 20 years old and you have survived. You passed linear circuits. You survived differential equations. You chose your specialization track, embedded systems and digital design, because a senior told you the job market was strong, and because IEEE 36200, Microprocessor Systems and Interfacing, was the first class where something finally clicked. You understood how an ARM Cortex-M4 processor fetches an instruction, decodes it, executes it, and writes back the result. You felt, for approximately 2 days, like an actual engineer. Then your signals and systems professor assigned a Fourier transform problem set due the same night as your digital logic lab report and your electromagnetics midterm. Your electromagnetics textbook is Engineering Electromagnetics by Haight and Buck. You have read Chapter 7 on transmission lines 4 times. You understand it less each time. This is not a metaphor. This is transmission lines. Your semester project is a digital thermometer. It reads temperature from a DS18B20 sensor, displays readings on an LCD panel, and transmits data over UART serial communication. It is due Friday. It is Tuesday night. The UART is not transmitting. You have been staring at a logic analyzer screen for 3 hours. The waveform looks like something a seismograph would produce during a moderate earthquake. You have applied for summer internships at Texas Instruments in Dallas, at Intel in Hillsboro, Oregon, and at Raytheon Technologies in Tucson, Arizona. The Texas Instruments internship pays $22 per hour. The Intel internship pays $36 per hour and includes free lunch. The GPA cutoff for Intel is 3.2. Your GPA is 3.18. At 2:14 in the morning on Wednesday, you find the UART baud rate mismatch. You fix 1 line of code. The LCD displays the correct temperature. You sit back in your chair and feel something that is not quite pride, but is in the same neighborhood. Intel calls on a Thursday. They made an exception on the GPA. You leave for Hillsboro in June. Level 3, Engineering Intern and New Graduate. You are 21 years old and you are sitting in a glass-walled conference room at Intel's Jones Farm campus in Hillsboro, Oregon. A staff engineer named Marcus, who has been doing this for 19 years, is explaining why your first design idea will not work. He is patient about it. That is somehow worse than if he were not. Then he draws the timing violation on a whiteboard, walks through the actual solution, and for the next 45 minutes you learn more than you did in a full semester at Purdue. You write everything down. You fill 6 pages. Intel's Hillsboro campus runs across the Jones Farm and Ronler Acres complexes and employs over 12,000 people. Your internship is in the Platform Engineering Group. You write Python scripts to automate test vector generation for a next-generation chipset validation suite. You earn $36 per hour for 40 hours per week, across 12 weeks, approximately $17,280 before taxes. Intel puts you in the Marriott Courtyard in Beaverton. The commute is 11 minutes. You feel like an adult for the first time. Back at Purdue in the fall, you sit for the Fundamentals of Engineering exam in October. It costs $175, runs 5 hours and 20 minutes, and covers mathematics, circuit analysis, electronics, electromagnetics, signal processing, and engineering economics. You pass on the first attempt, your score lands in the 83rd percentile. You graduate with your Bachelor of Science in Electrical Engineering in May. Your starting offer comes from Raytheon Technologies in Tucson, Arizona. The base salary is $68,000 per year. The annual bonus target is 10%. There is a signing bonus of $5,000 and full benefits from day one. Your first assignment is antenna feed network design for an airborne radar system. Your badge photo looks like a person who is trying very hard not to look terrified. You are terrified. You show up anyway at 7:45 every morning. With a notebook full of questions, you release one at a time so you do not seem unhinged. Someone will build what you draw. That fact changes your relationship with every decision you make. Level 4, Mid-Level Electrical Engineer. You are 27 years old. You have been at Raytheon for 5 years. Your title is Engineer 2. Your salary is $94,000 per year in Tucson, Arizona, which goes considerably further than it would in San Jose. You have your professional engineer license in the state of Arizona. It required 4 years of documented experience under a licensed PE and a 10-hour exam administered by the National Council of Examiners for Engineering and Surveying. The exam costs $350 per attempt. You passed on your second attempt. You do not dwell on this. You now own your designs. Your name is in the Configuration Management Database as the responsible engineer for 3 subsystem designs inside a classified airborne electronic warfare program. In public, you describe it as a box on an airplane. You have a cubicle with a second monitor. You go to lunch at noon. You know where the good coffee is. You use Cadence Allegro for PCB layout and Mentor pads for schematic capture. One current design involves a microstrip transmission line filter operating at X-band 8 to 12 GHz, and getting the impedance matching right took 3 weeks and 4 simulation iterations in Keysight ADS. You think about transmission lines now the way you once thought you never would. You understand them completely. Chapter 7 finally surrendered. Your team works to MIL STD 461 for electromagnetic compatibility, a military standard specifying exactly how much electromagnetic interference your hardware may emit and how much it must survive. You have memorized the relevant test limits the way some people memorize song lyrics. You bought a house in Marana for $315,000. Your mortgage is $1,800 per month. You drive a used 2019 Honda Accord. You do not miss the Beaverton Marriott. A senior principal engineer named Dr. Linda Vasquez asks you to lead a new subsystem integration effort. You say yes before she finishes the sentence. It is the first time anyone has put you formally in charge of other engineers' work. You go home that night and sit very still for a while. Level 5, Senior Electrical Engineer and Technical Lead. You are 33 years old. Your title is Senior Electrical Engineer. Your salary is $127,000. You lead a team of 6 engineers, 3 mid-level, 2 junior, and 1 intern. You are responsible not just for your own designs, but for reviewing and approving everyone else's. You attend 3 times as many meetings as you want to attend. You have learned that engineering at this level is 40% design, 30% documentation, 20% communication, and 10% finding out why something that should work does not work. That last 10% is where you actually live. Your current program is a ground-based signals intelligence system. You own the power distribution architecture across 12 subsystem line replaceable units totaling over 4 kilowatts of distributed direct current power. Power budget meetings happen every 2 weeks. Every engineer presents their subsystem's current draw, thermal dissipation, and margin. The margin is never enough. This is a constant. You use MathWorks MATLAB and Simulink daily for system-level modeling. Your most junior engineer, Jamie, runs signal integrity simulations in ANSYS HFSS with a fluency that impresses you. You tell him so directly. You remember Marcus at Intel. You try to be that person now. You have presented at 2 IEEE symposia, the 2029 IEEE International Symposium on Electromagnetic Compatibility in Detroit, and the 2030 IEEE Radar Conference in San Antonio. You are one of 2,900 members of the IEEE Electromagnetic Compatibility Society. Your performance review last year rated you exceptional in technical contribution and meets expectations in leadership. The comment reads, "Developing well, continue to build presence in cross-functional reviews." You have read that sentence 40 times. Your daughter was born 14 months ago. She does not care about X-band. She cares about a stuffed rabbit named Gerald and about whether her crackers are broken, which they must not be. You leave the office at 5:15 most days now. You have stopped apologizing for this. Northrop Grumman calls. The offer is $168,000 plus relocation to Redondo Beach, California, and a path to senior technical fellow. You have a mortgage, a daughter, and a version of yourself you have not yet become. You take the offer. You leave Tucson on a Tuesday in March with a moving truck and a car seat and a stuffed rabbit named Gerald who nearly gets left at a rest stop outside Blythe. Level 6, Principal Engineer and Systems Architect. You are 40 years old. Your title is Principal Electrical Engineer at Northrop Grumman. Your salary is $191,000. Last year's bonus paid out at 100% of target. You live in Redondo Beach 12 minutes from the Pacific Ocean in a house that cost $1.1 million and required a jumbo mortgage you do not contemplate before 11 in the morning. You are a systems architect now. You do not design individual circuits anymore, except to prove a concept or to settle an argument. You define requirements. You allocate budgets, power, thermal, signal, mass, volume. You write the document that tells every engineer below you what constraints they must live inside. You decide where the walls go. Your current program is Mission Systems Electronics Integration for the B-21 Raider. You work in a sensitive compartmented information facility. Your badge requires a Yankee white clearance. The B-21 Raider was unveiled at Air Force Plant 42 in Palmdale, California, in December of 2022. Its first flight was November 10, 2023. Unit cost is estimated at $692 million per aircraft. The Air Force intends to procure 100. You own the Electronic Warfare System Architecture document. 412 pages, controlled, updated every program increment. You travel 8 to 12 days per month. Monthly reviews in Palmdale, quarterly contractor reviews at Wright-Patterson Air Force Base in Ohio, twice yearly milestone reviews at the Pentagon in Arlington, Virginia. You have a preferred seat on the nonstop from LAX to Dayton. The flight attendant knows your coffee order. You are an IEEE senior member. You have been asked to join the IEEE Aerospace and Electronic Systems Society's Technical Committee on Radar Systems. You mentor 2 senior engineers formally through Northrop's Engineering Excellence Program and 3 more informally because they started following you to lunch and you never told them to stop. Your home office has a whiteboard that covers an entire wall. There are 4 simultaneous system diagrams on it in 4 different colors. Your daughter, now 7, calls it the wall of problems. She is not wrong. The program's chief engineer announces her retirement. She pulls you aside and tells you she recommended you as her successor to the VP of Engineering. You have never wanted anything this much, and you have never been less certain you deserve it. You spend the weekend on the beach not swimming, just sitting, watching the water do what water does. Level 7, Chief Electrical Engineer and Technical Fellow. You are 46 years old. Your title is Technical Fellow and Chief Electrical Engineer for the B-21 Mission Systems Program. Your total compensation is $268,000, base salary, annual bonus, and long-term incentive stock vesting over 3 years. 14 principal engineers report up through a matrix organization that you manage through influence rather than direct authority, which is harder than it sounds and more powerful than it looks. You are responsible for every electrical design decision on a program with a total contract value exceeding $20 billion. When something breaks in test, and things break in test, your phone rings first. Not because you will fix it yourself, because in 12 minutes you will determine whether it is a design flaw, a workmanship defect, or a test setup error. You are right 9 times out of 10. The 10th time you know exactly who to call. Your team runs formal design reviews aligned to NASA systems engineering processes. Every critical design review requires a failure modes and effects analysis, a reliability prediction, an electromagnetic compatibility assessment, and a thermal model validated against measured data. You chair these reviews, you ask the questions that nobody else thought to ask. You have been asking questions in notebooks since you were 21 years old in a Beaverton Marriott. The notebooks are different now, the questions are harder. You have been elected an IEEE Fellow, a distinction held by fewer than 0.1% of IEEE members, awarded for extraordinary accomplishment in the electrical engineering profession. The citation reads, for contributions to airborne electronic warfare system architecture and electromagnetic compatibility methodology. You receive the notification by email on a Tuesday afternoon while eating a sandwich at your desk. You sit with it for a long moment, then you finish the sandwich. You speak at universities now, you go back to Purdue once a year and stand in front of students in a lecture hall and you can see, from the front of the room, the exact expression you wore at 18, the thin coating of excitement over a foundation of quiet terror. You know something they do not yet know. You know that the terror does not go away. It changes shape. It becomes the thing that keeps you precise. Level 8, Distinguished Engineer and Legacy. You are 54 years old. Your title is Distinguished Engineer, the highest individual contributor rank in Northrop Grumman's technical career ladder. Your total compensation is $340,000. There are fewer than 60 people in the entire company who hold this title. You are not a manager. You have never wanted to be a manager. You are the person managers call when the problem is too hard for managers. You have spent 32 years learning one discipline from the inside out. You know things about electromagnetic interference propagation in complex metallic cavities that exist in no textbook. You know them because you measured them, failed to predict them, built better models, failed again more precisely, and eventually built models that were right. You have written 23 peer-reviewed papers. You hold 4 patents, 2 of which are in active use in production hardware, flying on operational aircraft right now, tonight, somewhere above the Earth. Your current work is at the intersection of directed energy systems and advanced electronic protection, a frontier where the physics is settled but the engineering is not. You chair the IEEE Aerospace and Electronic Systems Society's technical panel on electromagnetic survivability. You sit on the Department of Defense's Scientific Advisory Panel for Electronic Warfare Resilience. You have testified before a Senate Armed Services Subcommittee. You wore your best suit, you brought data. You think about Marcus sometimes, the staff engineer at Intel who patiently dismantled your first idea and then handed you something better. You have been Marcus to more engineers than you can count. Some of them are principal engineers now. One of them is a technical fellow at a competitor. You consider this a success. Your daughter is in her 2nd year at Georgia Tech studying electrical engineering. She called you last week from a lab section at 11 at night. The UART was not transmitting. You talked her through the baud rate check without telling her the answer directly. She found it herself at 11:43. You could hear it in her voice when she did, that thing that is not quite pride but is in the same neighborhood. She has a lab partner who pre-reads everything. She has not pre-read everything. She has a whiteboard covered in equations that are mostly wrong. She is sitting in a lecture hall right now that holds 280 students, and a professor is drawing a phasor diagram and she does not yet know what she is walking into. She is going to be fine. She does not know that yet either.
Hey, if you made it to the end of this video, thank you. These stories take a lot of time to put together, so do me a favor and hit the subscribe button and leave a like. It means a lot. See you in the next one. Bye.